Alright guys, so for these first couple problems, we're really just working with order of operations, which means you have to use your please excuse my dear and Sally. So you got to do what's inside the parentheses, and then you do your exponents, and then you multiply, you divide, you add, and you subtract. So when we look at this problem, we get a set of brackets, which is really just a special set of parentheses, which says these two go together. And then inside these parentheses, there's another set of parentheses inside. So this set of parentheses is actually going to come before the outside set of parentheses. So inside the big parentheses, which you have to do before you can do division, we have to still follow the order of operations. So in here we have subtraction, multiplication, parentheses, and inside the parentheses we have to do those order of operations first. So we should be doing the 7 minus 2. So when we bring this down, 384 minus, now don't subtract this and make it like 381 because this is 3 times something. And what was it times? Well, 7 minus 2 is 5. And, oh, lost my 3. So minus 3, 7 minus 2 is 5 to the third. And then afterwards we got to divide this by 3. So now what do we have? Inside the big brackets, which are still there, we still have subtraction, we have multiplication, we have exponents. So you still got to stick with your exponents. So 384 minus 3, 5 to the third, 5 times 5 is 25 times another 5 is, think about like 5 quarters, is $1.25. Still divided by 3 afterwards. And then from here, we have to do our multiplication before we can do our subtraction. So 384 minus 3 times 125, 300s and 3/4 would be about 375. Once we have that answer, see, I'm starting to use parentheses here instead of brackets on accident because they mean exactly the same thing. We have brackets divided by 3, so now we're inside of our parentheses, these brackets. I have to do my subtraction before I can do any division. So 384 minus 375 should be just 9. So now we have 9 divided by 3, which is 3. Now, if you have your TI-83 calculator, you can write it directly the way you see it, and you should get the exact same answer. Now, problem like example 2 is exactly the same, except for the fact that we have to plug in our values. So we got x squared here. We know x equals 5, so it's 5 squared. Everything you plug in, you should put in parentheses, times the y, which is negative 2. All of that over x, which is again 5, times the z, which is the negative 1/4. Alright, so try to do this without the calculator. 5 squared is, and again, you got to do your exponents before you can multiply. So 5 squared is 25, so we get 25 times a negative 2 divided by, well, 5 times the negative 1/4. You put this 5 over 1, and you get a negative 5 over 4, because you just multiply across and you multiply the fractions. So what do we get? We have a negative there, negative 50, because a positive times a negative, there's only one negative there, over a negative 5/4. So how do we divide something by a fraction? Well, we end up multiplying by the reciprocal. So this jumps up and becomes a negative 4 over 5. Now, we've got a whole number by a fraction. It might be easier if we make the whole number a fraction itself. So we end up getting a negative, well, 50 times 4 would be 200, so 5 times 4 is 20, extra 0. But we have two negatives, so that makes it a positive 200 divided by 5. It's 5 times 1. And so 5 goes to the 20 4 times with a 0 afterwards. A slightly shorter way of doing this is you can cancel the 5 with the 50 and make it a 10. So negative 10 times negative 4, positive 40. Alright, let's skip to this application problem here. And your job is to go back and do any problems that we skip using the same ideas. That should work. Okay, so we got the area of a trapezoid given by this formula. It's basically just the average of the two bases times the height. If you forget what a trapezoid looks like, it's this overall shape, kind of like a cut-off triangle. And where these two sides are parallel, so a triangle is 1/2 base times height, but you have two bases, this base and this base, so it's the average of the bases. Add them up, divide by 2. So a lot of times you see this formula written this way, but it's still the same thing. Alright, so we got two heights. We got the height, which is this height, always perpendicular. We got the two bases, base 1, base 2, or base 1, base 2, doesn't matter. So the area is just going to be 1/2 times the height, which is 10, times the sum of the bases, 16 plus 52. Now for the order of operations, you got to do your addition, but you can do this half of 10 right now. So it's going to be 5 times, what would we get, 78? Nope, 68, sorry. And so 5 times 68, if you don't have your calculator handy, then you just kind of do old school multiplication. So 44, 30, and 4 is 34. So we get 340. And if we're looking for units, areas always are units squared, so inches squared. Alright, so for simplifying these expressions, I'm going to do the tougher one and leave you the easier one to practice with. Basically you want to combine like terms, but you got to distribute whatever's out front first. So we're going to distribute this 1/5 into each of these. Now, the way you want to think about this is we're multiplying by 1 and then dividing by 5. So 10 times 1 is 10, divided by 5 would be 2. So that's 2a. 1 times 15 is 15, divided by 5 would be 3, so minus 3b. And then we're going to do the exact same thing with this half. Now if it was a negative half, you distribute the negative also. So in this case, you're going to distribute a -5. But just a regular old half. So 1 times 8 is 8, divided by 2 would be 4. And then the same thing with the 4. So 1 times 4 is 4, divided by 2 would be 2. And now when you're combining these like terms, 2a plus 2a would be 4a, not 4a squared. It's like 2 apples and 2 apples is 4 apples, not apples squared or anything. Negative 3b plus 4b, you can rearrange it and think of it as 4 minus 3, but you owe 3 and you get 4, so you have 1b. You don't have to write the 1, but you can. And that's our final answer. Alright, solving equations, your number one rule is to get everything on one side of the equal sign, all the variables on one side of the equal sign, all the numbers on the other. So let's do this with b, because that looks like the most complicated one, and leave the other two to practice on your own. So we do what we did in the last step, and we distribute our variables. So we get 5c minus 40, so distribute the number, sorry. And then same thing with this quarter here. So 1 times 2 is 1 divided by 4. 2 over 4 would be a -1/2. And then we take this -1/4 of 12. So 1 times 12 would be 12, divided by 4 would be 3. But we're distributing a negative, so making it a -3 equals -23. So now, let's combine our like terms on the left. So if I wanted to combine 5 minus 1/2, it might be easy to do this as a decimal, like 5 minus decimal half is 0.5, that'd be just 4.5. Pretty quick. But if I want to keep this as a fraction, I got to put this over 2. So multiply top and bottom by 2. So this would be 10 halves minus 1/2 would be 9 halves. And then minus 40 minus 3 is -43 equals -23. And then we have our c's on the left, so we put our numbers on the right. And you get 9 halves c equal to 43 minus 23 would be 20. You notice that I'm doing that in either order. So -23 plus 43 is the same as 43 minus 23. Alright, we want to get rid of a fraction. So if you want to do this as a decimal, that's fine, and you divide by 4.5, and then you need your calculator. If you don't want to use your calculator, you're going to multiply by the reciprocal to get rid of the 9 halves. So you multiply both sides by 2 over 9 times 2 over 9. And over here on the left, the 2's cancel, the 9's drop, and you're left with, well, 20 times 2 would be 40 over 9, which doesn't reduce anymore. So the decimal for 20 divided by 4.5 would be the exact same thing we would get with this fraction. I don't care if you do the decimal or the fraction, but as long as you're showing your work and giving me the answer as the right answer. Alright, let's do a couple simplifying polynomial expressions. So when we do a problem like D, you're going to distribute just like we did earlier, but we got to be careful about our variables. So you multiply the numbers 10, x times x would be x squared, and then there's just a y, so just regular y. Then we do the same thing with the y. So positive times negative is a negative. 5 times 1 would be 5. X times no x is just x. Y times y is y squared. And then we do the exact same thing with this 6. So plus 6 Now, it doesn't matter if you go y squared x squared or x squared y squared, but the normal way would be to put the x's first just for alphabetical order. And then the last one would be a 36y squared. Now you got to check to see if there's any like terms. These two look very similar, but they're not exactly alike. This one's got two x's and one y. This one's got two y and one x. So if you did have like terms somewhere, you would combine them, but if not, you leave it alone. Alright, of all the problems on this little topic, the one that I'm worried about the most is f, because I'm going to get a lot of 16x squared plus 25y squared, and that's not what it is. Something squared means you're going to take itself times itself. So you're multiplying something by itself. So 5 squared is 5 times 5. 4x plus 5y squared is 4x plus 5y times 4x plus 5y. And then just like e, which I skipped in the video, but you can go back to after you do f, you're going to have to FOIL this out. So I don't really like, I just think of distributing. You're going to distribute the 4x, pretending that this, like if this 5y wasn't here, you would distribute the 4x to both of them. Okay, so that's what we do. If the 4x wasn't here, we would distribute the 5y to both of them. But that's really what we do. So we distribute the 4x, giving ourselves a 16x squared, and then a 20xy, and then we distribute the 5y into both, giving us another 20xy. And then the 5y times the 5y would be a 25y squared. Now the only thing we still have to do is combine these like terms in the middle. So 16x squared plus 40xy, and remember you don't add the exponents if you add them, only when you multiply, plus 25y squared. That's our final answer. It's not a hard problem, but a lot of people forget to do that first step where you write it times itself. So, for example, we're trying to solve for a particular variable. You want to really just kind of pretend that all these are numbers. So this is a number like 5, this is a number like 6, and we're solving for L. This is our x. You're going to solve exactly the same way as if it was 3 equals 6x plus 5. Almost everybody should be able to solve for x here. It's not any different in this case. So we've got to get everything away from the L. So we're going to move over the pi r squared. And we get s minus pi r squared equals, because you can't subtract these, they're not like terms, so you just write it. What's s minus this? Well, it's just s minus this. So pi r l, and then to get the l by itself, we got this pi times r in front of it, so we're going to divide by pi r. The steps are exactly the same as you would do over here. Over here, you'd minus the 5. Now in this case, 3 minus 5 is negative 2. Like I could write that. Over here, I don't know what it is, so you just leave it be. And I know you're trying to figure out like, well, what do we do next? Well, these just cancel out. They go away, and you get L equal to that. That's what we're looking for. Same thing here. Get the 8r over, and then divide by the negative 5.